And good evening, everyone who is watching the stream of VOD. Arrives on air, and welcome to my creative stream. Let's call it like that. I keep calling them creative. It's like the old school way to call them. So just give me a second here. It feels like my microphone, for some reason, is a little bit too quiet, like super quiet. Strange. The noise gate, the limiter, everything is there. Why is my microphone so quiet? I can hear the level of the sound is not that amazing. Let me take a look. There's like compressing and gating. Everything's there. Okay, let's just give it a little bit of a classic boost. Yeah. So like this. No, like this. A little bit of technical moments here. So I do the streams. I'm going to do more of them. Like, it's not just DIY, but it's sort of kind of preparation for DIY. So 3D modeling. I kind of always liked it. So I really... what is wrong with you today? F11 doesn't work here. Just give me a second. What is wrong? Okay. Now it does work. So I've always liked to sort of kind of play with sort of 3D modeling. My first experience, it was 3D Studio a long time ago, like 1994. 1995. So, but that was just making something, drawing something 3D. Here, it's about making something 3D. I've already done a stream like this. I was designing a case there. Today, it's going to be a little bit more complicated. Okay, let me actually prepare everything here. A little bit more complicated it's going to be. So let me remove this. So what it is going to be. So as you can see, there is like I have 8 cells. The format of the cells is called 33-140. So 33 millimeters in diameter, 140 millimeters tall. So very chunky boys. I bought them to make my own battery for pretty much low voltage UPS. So I happen to have a sort of kind of security system low voltage UPS. That's just a metal box with a couple boards in it. So it's not high power, nothing. But it can use a battery. It's capable of utilizing a battery. And I wanted to give it a really big one. So no big currents there, no big loads, but something that would last really for a long time. So I bought these. So these are, as I said, 32 or 33-140. This is 32-140. So 3.2 volts, 15 ampere hours, lithium iron phosphate, I think. Lithium iron phosphate cell. So the thing about them, I bought them because well, first of all, they are not your standard lithium ion. They are supposed to be way less dangerous when something goes wrong with them. some people say they supposed to be even be resistant to just damaging and puncturing them. So, but even these ones, they're going to be inside that metal enclosure. That's that UPS is security UPS. It's not like something. It's locally produced here, so a bunch of things like that you can buy, of course, on every local market, locally produced. So even though they're supposed to be safe, and that's why I bought them, they still going to be in a metal box on the wall where there's nothing to burn. So as you can see, they're pretty big, pretty chunky, like really chunky. So each one contains 15 ampere hours, so that's a lot, and together they're going to form a battery that's gonna be like your standard 12-volt battery with 30 ampere hour capacity. So you connect like in series 4 of them, you get around 12 volts, a little bit more, a little bit less. It's different, of course, from like lead acid batteries, but still. So, and then you just connect a bunch of them, like 2 in series and 4 in parallel, and you get 30 ampere hours out of this pack. So it's easy. I'm going to build this pack on stream. So, but today I need holders for them. As you can see, I bought, well, I mean, the guy who sold me these batteries, like supplier from China, got me these holders that kind of do the job, but it's my own personal problem here. With these holders, it doesn't fit in that metal box of UPS that I have. It's not small, it's not a big one, not a big at all. So again, it's just incapable of consuming any high currents. It's incapable of producing any high currents. So this is going to be more like for the longevity, not for the power. So I need another way to actually them to be held together. And then I kind of started looking towards hexagonal. Oh, this is loud. Hexagonal holders. So I've already experimented with some, designed some, but these are prototypes. These are not even real holders. So I designed some just to see if I can like get them in the right size. So like this and like this. These ones actually, yeah, this one's not right because it doesn't really fit here. So the size of this one wasn't right. So different ways of actually leaving spaces for the what's nickel strips. These are going to be welded together with nickel strips. So different ways I kind of come up with. So I ordered, well, I mean, I designed prototype number 2, like this and this. So as you can see again, the difference between, again, it's not like for the full pack, it's just partial design. Oops, I lost connection to my YouTube chat. It's been happening, but the streaming seems to be going fine. So it's like not the full one. The full one, of course, should contain all 8 batteries. It's like just prototype. Again, different ways. So this one you can put on and then solder, and then weld the nickel strips onto batteries, and then just remove it. This one you won't be able to remove without removing the strips first. So different designs. So, and this one is already better. At least I can fit the cells in here, as you can see. So, and it's kind of supposed to be like that, but it's supposed to be not 4, but 8 of them. So like this, it's just a prototype. I even realized, because the one that's not removable, it has this additional connections here, so it's pretty much circles, as you can see. But the one that's removable, it's actually not that sturdy because of no connections. It just consists of holes. So I even designed a way to make it a little bit stronger after just putting it in on the batteries like this. So again, this is only 5. It's supposed to be 8. It's just to save on materials for this prototype prints. So it's supposed to be like this, and then to make it stronger, I even made a sort of a cap, a lid, so you would do it like this. Again, I didn't think, of course, of how to route the strips, nickel strips, connecting the batteries outside. I didn't think of how to route the balancing wires for the balancers, but look, I kind of like that I managed to come up with very easily come up with this design that I pretty much without a single application of a file, look how it fits. It's like perfect fit. I think the difference in sizes between the outer wall and the inner, it's like 0.25 of a millimeter, so it's like a little bit thicker than, I think, a hair, something like that. So fits nice and stays even in there. But because first of all, I've been experimenting with the diameter of these battery holders, and first of all, I ended up in this prototype making them pretty large. So it, of course, goes inside, but it's super loose. I don't like it. Second, it's loose because this whole thing is just loose. It's not sturdy. Again, it's a prototype. It can be printed in a better way with more like filament used to build it. It's actually, I think it's semi-hollow inside. So if just we use a little bit more plastic on it, that'll make it way sturdier. But I kind of like this design where you can pretty much weld all the batteries together, and then the output ones you can just bend like down here through the gaps, and then if you need to remove it, you just bend it up and like raise it, and it won't the strips welded onto batteries won't prevent this holder from being removed. So but so this hexagonal holder takes a little bit less space than your standard rectangular holder, or it's like square holder, but still I have to experiment with what shapes I can give it. And because the situation there's like in that UPS, there's a board there's like some cable, a transformer. I just want to design several shapes, print them all, and then try them all just in situ. Try them all just inside the thingy. Okay, so let me take these away. They're chunky, they're pretty heavy. I don't want them to just rolling around and falling off the desk. So let me just remove it. So it's pretty cool, and I got it for the price of let me calculate. Do I have a phone here? I have a computer here, but it would be easier on the phone. Am I streaming? Yes, I am. Okay. Calculator. It was crap, I forgot the exact price. Okay, let's take not the exact one. Let's take roughly what I remember what it was. Roughly $60 for all this. Of course, it's going to require the proper holders. This one's not going to work for me. It's going to require a balancing board, because when you charge them, these cells inside the assembly, they got to be all balanced. They got to be all at the same levels. They'll make them work longer. But otherwise, $60, and this is like 12-volt, 30 ampere hour batteries with like supposed to be super serious amount of cycles. Like, I don't remember, 3,000, 2,000 cycles. And that's going to be used in an UPS for low voltage devices. So pretty much 12 volts and around. So UPS, originally it was a UPS for surveillance cameras, old ones, analog ones. So going to repurpose it for my own stuff, including like ability to charge your phone when you end up not having like the mains power in case of a power outage. Feast, good evening, welcome. Yeah, but today I'm not assembling the assembly. I'm only going to model the holders for it because it doesn't fit where it's supposed to be. Okay, so let me take this away. Ganegecha, good evening, welcome. Nice to see you. Hope everything is okay. Feast, yeah, that's a very serious cell phone battery. Yeah, super serious. So, since this is like not my first design, so old back phone, yeah. Since this is not my first design, this is going to be the third design. I already have some experience here, so I'm using Tinkercad for this. It's like reasonable enough, easy to use. And just give me a second. What I need to do, I just need to make a couple of designs for this holder. So I already have here a couple of things. So this is like the hex for the holder, the base of the holder. So, and this is the battery itself, the diameter of the battery. So I first tried to do them in like 33.25 in diameter, then 33.75 in diameter, and I think the truss is somewhere in between. It's like 33.2 in diameter for the ones that I have. The manufacturer calls them 32 140, so 32 millimeters, but in fact the holder for them should be around, I think, 33.5. So let's start making it. So that's already raised. So the battery was the size of two cells. Yeah, back then. So that's the proper hex for the holder. So I don't have a 3D printer. I do not know that all those tricks. I just do the design, send it, it gets printed, and then I get it back and I look at it. So iterative manufacturing, so something like that. What I want to do, I want to make, for some reason it ended up being not like any round number. To make them a little bit sturdier, I want to make them like, oops, that's I can use the keyboard here, my bad, just give me a second. So that's what it's going to be. So that's what it's going to be. Both of you move out. So let's cut a hole in them. Here we go. So we have a hole now for the cell. So we have exactly one cup. one cap. Yeah, Fist, yeah. I'm trying. I'm kind of learning things here. So this is our one exactly hexagon for one side of one cell. Okay, now let's make a hole for the contact. That's already I measured. That's already good. So here it's just what I'm going to use. This diameter 22 millimeters for the hole. Fusion 360, is it free? So I will have to learn better than Tinkercad. I will have to learn more powerful things. I have already a need for that. But this can be done in Tinkercad, yeah. So here we have a hole. Okay, let's copy it. Just all the steps gets copied. Oh, cool. Okay, I'll have to try it. I really need something more powerful. I wish I had more time to learn that stuff. So here we have one cell, one holder for one cell. Now, since I'm going to use this type of design, so that's an old one. So pretty much the ones that can be put on and removed even with the nickel strips well to the batteries. So I'm going to actually cut pretty big holes in them just for that reason. So we have one. Let's turn it upside down. Cool, Fistmaster, cool. I haven't actually moved in my retro PC stuff anywhere yet. So let's start with building blocks. The standard building blocks of this would be like I've already designed, but these are round sizes. So this is completely new, and this is like pre-prototype. 3D Studio Max still wow, you got the license. No, it's still good, so let's start building the elements we need. So you again as a step go here. The cutting element, this represents the size that I need to cut them. This represents the hole that I need to cut in them. So, and I'm just going to do it like this. So one we have already ready. Well, I mean, this is not going to be used anywhere. It's just another step of the design process. So, and this has to be just aligned like this, and then moved into this. Hey, it's not even tall enough. Ah, yeah, I moved it sort of kinda. Here we go. So this is gonna be the step. Save it. And the first building block of the holder. Here we go. That's the first building block of the holder. That's number one. The rest are going to have actually two of the cuts. So let's keep cutting them. The easiest would be one on the other side first. Hey, not the whole assembly, please. So centered, yeah, centered. Everything is centered properly. Copy, save. and make the cut. Here we go. That's the one for the strip that comes in and then comes out. So yeah, pretty much. You go here. Now we take this one and use it to make another one. So first we got to turn this one. We got no, do not change the size of it. Oops, do not change the size of it. So we got to turn this one like 60 degrees. That'll do for now. Again, align it and move it in. Make a copy of it. Let's do it like this. Oops. Made a copy of it, and let's do the cut. Cut. Unionized union group. Okay. No, this one is done. Then we take this one again. Not like this. We use the cutting block. So turn it 120. Oops, didn't work. What just happened? Something happened. When you don't know what happened, it's better just to press Ctrl Z and undo it. If something happened you didn't see, it'll be rolled back. If something happened that you saw and that you need, you can always roll it forward. Okay, so this goes 120. And this is going to be, I think these are going to be all the elements we need, right? Right, they're kind of symmetrical. They have this type of symmetry, hexagonal symmetry. So already centered, really. So this is going to be a strange one with a small tiny sliver of material left there, but they are not going to be a single one of them. Not a single one of them is going to be separate. They're all gonna form a larger structure. Did I move it? Yes, I did. Okay, cut. Forgot to make the copy of it. So we need the copies. Okay. I kind of don't like, did I? No, it's all aligned. Okay. Make the cut. End up with this tiny sliver, but it's all gonna be connected. So now we have all the building blocks to start actually building the holder. It's gonna be a little bit tricky because conjoining these details, making them sort of kind of connect properly here. I have a feeling that quite sometimes it would be like this software, which is a web-based software, would leave tiny gaps between pieces that you need to join. So I kind of go on a micro level where you'd be moving just 1/100th of a millimeter, operating on this level, sub-millimeters, around 100th of a millimeter level, and I would just join them on that level. So okay, let's start building. The first shape I wanted to do, the shape for 3, 2, 3. So, and we'll have to use them to assemble actually, we have to think of the paths for the nickel strips at least. Plus we have the like input and output. That's gonna be strips too. Plus we have the we have the wires coming from the balance board, but I think I'll think about them a little bit later. So first we just got to get the basic shape going. So one going to be like this. So let's imagine it starts here and it joins two batteries in parallel and then switches to another two in series. So then it has to be like this. Just already gonna do aligning them like this. So, and then move them in. I don't know the best way to join them, but this way. So, and then I go on a sub-millimeter level, which would be something like this. So see, there's like a gap. I think this is like, I don't know, less than 1/10 of a millimeter. So like this. Unfortunately, this is the smallest I can move these ones with arrow keys. So maybe with the mouse I could move them even less, but it's left and right, up and down. So this level of precision is like 100% enough. So we have two. Now the third one's going to be this one. So first of all we turn it. Did I change its size? No, I did not. I wouldn't want to change the signs of these hexagons because that's like super annoying. You got to be turned 60. Minus 60, apologies. Like this. And then this goes here, like this. Moves in roughly. Moves in precisely. So if you don't do that, if you leave gaps, this software on export might start doing pretty strange things with your model. So this is like two batteries in series here, in parallel here, and then goes to the two batteries, another two batteries. So these connections are like parallel, and this is like connection. It forms a serial connection. Okay, now we need another one that's going to be this one. So now in order to align it, center it properly, I'm going to turn whole assembly like minus 60. No, not minus 60. Minus 30. So this I'm going to turn minus 32 like this, and this will give me the opportunity to align it the easiest way possible. Here we go. It is aligned. Move in roughly, then like this, properly joined. Now turn the whole assembly back, minus 30. So no, I didn't do it right. It's not the element we need here. This element we are not going to need. So we are going to need this element because 2 in parallel, series, 2 in parallel. So we are taking this element because there is not going to be a connection here. It's going to be on the other side, as far as I understand. So again, turn it -60 on -30. Okay, 30. Then that's easier. This 90. Come on. So then we align it. At least this aligning thing works. We align it. We align it. What's the hotkey for aligning? Actually, got to take a look. Does it say? No, that's mirror. L. Okay, the hotkey is L. Got to learn the hotkeys here. It's very basic editor, super basic, free, absolutely. Works in a browser by Autodesk, I think. You can do whatever with it, and for basic things like this, when you work with primitives, it's perfect. I think you're not going to need anything else. Okay. Oops, misaligned it. Okay, now the microscopic fusion between two parts, like this. And here it has to be roughly the same level of fusion. Microscopic, yeah. So I'm doing this like the easy way. So to connect here, then to connect here, right? So let's kind of imagine how we need it to be. So 30 back. So to connect here, to connect here. Then to connect on the other side, right? So they connect in two. So no connection here. They're going to be connected on the other side, and this connection on the other side would go to, so it's going to be pretty much mirrored. This is going to be mirrored on the other side. Wait, am I doing it right? Just a second. So, okay, let's experiment then. If we cannot figure it out, let's experiment then. So, for example, this is going to be like this, then to connect to like this. It cannot be any other way around. I'm just figuring out where the connections should be. So like this is the shape we need. So these two are connected in parallel, then series connection in parallel, then on the other side it connects to these two. So these two, this connection. What connection should happen on this side? I'm kinda having a huge brain fart here. So this is easy side. So that this connection from this to this one happens on the other side. Then two connected in parallel, that happens on the other side. Is it gonna be like fully mirrored? All the connections, all the other connections happen on the other side? No. Yes. So the other side, on this side is going to be no more connections. Is that what I'm trying to do here? So if it's like this, this, no, the connection on this one. Crap. I'm having a brain fart here. So definitely the one that's gonna be here, it's not going to have a connection. Or is it going to? Or is it going to be like full mirror here? With only one connection on the other side. So here we have 1, 2, 3, and then 1, 2, 3. Looks like it. So this one's not connected. Because this is one in parallel, so pretty much one big cell. This is one big cell. This is going to be one big cell. And this is going to be one big cell. Getting myself bamboozled here. But definitely there's no connection between these two here. It happens on the other side for sure. But then if it happens on the other side, then it has to happen with the next one too, right? So what is it going to be on the other side then? Trying to internally visualize it. So one thing I know for sure, that no connection here on this side. So it's gonna be either this one or even like closed one. Yeah, this type of design is a little bit hardcore. So minus to plus. Then on the other side it's going to be minus to plus. Yeah, I have a feeling that on the other side it's going to be all connected like this, right? So this is, for example, like top side of the assembly, and the other side I'm talking about would be the bottom side of the assembly. Normally they would be like rectangular, and they would be actually connected like this. Let me show it to you, camera. So they would be connected like this, like this. So I have them in a different different assembly. So I'm going to have them. So this and this are all getting connected, and because these two are in parallel, so it's all like getting interconnected here. But then it goes to the other side. Let me where's the second one? Where's the second holder? So these all get interconnected. 3 pairs in series, 4 pairs. That's 4 because they are 3.2. 4 pairs in series. So on this side, let's turn it. This gets interconnected. And then again on this side, this gets interconnected. Am I right? Yeah, I think. So what does it give us? Then connection here, like this all connected, here this all connected, and then here this all is connected. So we have a little bit different configuration here. That's a wrong key. We have a little bit different configuration here. So it looks like it's going to be like this. 120. Align. Join. Not like this. Like this. And then on a micro level, on a super micro level, like this. So one pair connected to the second pair, then they connect on the other side, 2 pairs. So parallel, series, parallel, series, parallel, series. Yeah, I think it has to be something like this. Okay, then for this side we take then this one. Let me get the cells out of the way, big and heavy. So this has to be turned 120. Ah, no, 120, 120. No. First we turn the assembly. -30. Then we take this one and turn it 90. Align it with this one. Then move it in. Not the whole one. Not the whole thing, just these two. Again, fusing them together on a micro level, like this. Then turning it back 30 degrees, like this. and this is one pair. So again, parallel, series, parallel. On the other side, series, parallel, series. So for example, like two pluses, two pluses, two minuses. Then plus connects on the other side, plus connects to minus. It's going to be two pluses here. No, it has to be two minuses. Well, according to the simulation I've just done on the rectangular holder, it's like pretty much it has to be like this. Okay. Okay. So let's see if it's going to give us anything at all. So you go here, align, move in, micro level fusion, like this, and then the last one, and then the last one is going to be this one. All right, 180 please. Plus, minus, plus, minus. Okay. Micro level fusion. Okay, this is one side's done. So as I imagining it myself, it looks exactly OBS, what's wrong with you? My bad. It looks exactly like this one, but in a different configuration. So one pair connecting to another pair, then connection on the other side, then again one pair connecting to another pair. So yeah, something along those lines. Okay, let's consider one side's done. No. I'm bamboozling myself really hard. So disconnecting here. So if this connects here, then we disconnects here, disconnects here, disconnects here. So then the outputs of the battery is going to be on the other side, minus on the other side here and plus on the other side here. Right. We are looking here at a side with no output. So actually we've designed the bottom. Let's consider the side where you can like attach something to the battery at the top of it, just like a car battery would be, and the side with no connectors on it, that's gonna be the bottom. So we've designed the bottom side, I think. Then I think, yeah. Okay, let's join this. Not in a union, just bundle. So this is one side of it. Then let's start with another side. First is going to be the outputting terminal. So the terminal of the battery is going to be, but I'm going to make those sorta kinda the last thing. So technically, because this is not going to be connected to anything, it has to be like 1, 2, 3, 4, one connection, 1, 2, 3, 4. I think like this it has to be. It's gonna be structurally more sound than I kind of thought it would be. Okay, then. I never designed the battery packs before as on this scale, and I never made holders for them, so this is my first one. Okay, micro level fusion. So the terminal is going to be here. Positive or negative doesn't matter. One of the terminals going to be here, and I think I'll make just. We will see how what would be the best way to actually attach it. I think the strip, the nickel strip, is just going to be welded here and go either like this or like this. So I'll have to cut a little bit, a tiny sliver of material off of here to let it to be like completely flush, not going over the surface. So okay, another one goes here, gets aligned again, already is, then gets microfused, and then here the center is going to be our connection. So then we take one like this and start turning the assembly again. So we need it to be turned like I lose ability to turn it. 30 degrees. Then you has to be like this, then like this, minus 150, really, 120 plus 30, yeah, 150. So you get aligned. The snap. And the microscopic fusion. On the microscopic level. Like this. Turn the assembly back to normal, -30. Then we take this one, turn it 180. 180, I said. Is it so hard? Not 180. 0 degrees we turn it. I just realized we do not turn it at all. Would you please? What's wrong with you? Here we go. Align, snap, move it in, micro level fusion. Micro level fusion. So this is the only connection that happens on this side, but terminals are here and then going to be here. So I could copy this one there, but I think I'm just going to build them the way I build the first one. Just assembling them from pieces, turning the whole assembly the way I need it to be turned. So I think I'm going to be using like 15 millimeter 0.2 thick nickel strips for welding the batteries together, but I don't have anything yet. So, and that'll give me like 15 amps. So I think one 15 millimeter 0.2 nickel strip rated max, continuous max current 15 amps. If you want to add on it, you'd have to like stack them, weld like 2 strips on top of each other, which is possible. But I don't think this battery, well, I mean, where I'm going to use it, I don't think it's going to under any circumstances to experience currents more than like 5 amps. And that's like probably the absolute maximum would be. So it's going to be a low power thing. It's not a bike. It's not a real UPS with like DC-AC adapter inverter. Micro level fusion. So it's going to be a low power UPS. -30, go back to normal, and we take you and you go here, and we align you with this one, and then we move you in like this, and then we do microfusion. Here we go. And then we do the last one. So move out of the way. Should be actually aligned, but let's realign it just in case. It shows that it is aligned. So the only thing we have left to do would be like microfusion. Okay, so this is the top, this is the bottom. Oops. The terminals are here, one here and one here. So thinking about the best way of placing them, because even though we're operating like terms like the top cap, the top holder and the bottom holder, actually I think these are going to be sides if it fits inside the assembly, if it fits inside that UPS metal box. So if it's on the side, then what's the best way to get the terminals out of it? For example, it's on this side, then it should go like here in order to not make contact with the case, metal case, and like, yeah, they should go like inside, sort of kind of inward they should go. Okay, so let's do some cutting here, at least for these nickel strips. The best way to do it, get this out of the way. Again, turn it, -30. Take this thing, take it here. Is it 15 by 15? Yeah, it's 15 by 15. Align with this one. Like this. Move it in. All the way like this. And then 1 millimeter. So this is the top. This is the thickness of the top part of the holder. So if you do the cut, it's going to be like this. So we cut the top part of the holder completely. So yeah, you go here, cut. So the strip is going to be weld here and then go here, bend. Well, on this drawing, it looks like it represented like it goes down, and then here it gets like it's a terminal. It forms a terminal pretty much. So then you go here, get aligned with this one, and you go here, right. Cut. Here we go. So these are our terminals. Turn the assembly back to normal. So, or maybe even this side, it would be better to move it to, if it's like on its side. I'm just trying to place it inside the box. I don't want to redesign everything because of one small cut made in the wrong direction, but a reprint. But again, not that I'm in rush with this design or anything. So if there's a mistake, and probably there is a mistake somewhere already, we can survive it. So, okay, now this is ready then. Let's copy it outside. Union, but make it like a bundle. I don't need it completely unionized. Bundle, okay. So this is bundle, this is bundle. Now we are going to make a cap for them. Nobody does the caps. I'm going to, because I'm like that. I want to have a cap. So for that, we are going to do what? We are going to take this here. So this is just slightly larger. So if you do it like this and completely align it, let me show it if it works like this and like this. Yeah, it goes completely inside. So this thing goes completely inside, but as you can see, it forms sort of the walls. If you just take all this volume here and subtract it from this hexagon, we'll get pretty much a perfect cap. So that's what I'm going to do. I'm going just to take these hexagons and put them on top of this assembly. And they are 2 millimeters taller, so they're supposed to be 22, right? Yeah, they're 22. Pum, 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 pum. Okay. No. You go here, you go here. They're intersecting, but that's the way to do it. This part I've done already, just not the full size of the things. A, align. Lost the alignment menu. Here we go. And then this one. Align it with this one. Then take it like this. Align with this one. This side's aligned. This one goes here. And this one gets aligned. Is it properly aligned? The last one I kinda didn't like. What's wrong with it? Let's try it again. CV. Alignment. This. Huh. This one ended up out of alignment. Is this one aligned though? Yeah, aligned. Okay. So this is the cap. Now we have to do cuts in the cap. That's like actually pretty easy. You take this one. That's the size, the volume I need to cut out of them to form the cap. And you align them with this. Align, align, align. Let's just do the cutting right away. Here we go, and we remove this one that's inside hiding, and we get the perfect empty hexagon that would fit any of these hexagons. Let's leave like one here. Align, align, align. Can I please have them selected? Oh, I need to cut out these two. Crap, I forgot about them. Yeah, my bad. My bad. Not like this. So before cutting, you do it like this. Then you select this one, and this one. And that's how you cut. But then they would be joined. How did I? I've done it before. How did I do it? Yeah, I know how. I'm stupid. I'm super stupid. You just got to place them all first. Place all the cutouts first. So all the volumes that need to be cut, you place them first. That's not the right one. For some reason it shows it's whole. Yeah, the green is just the way it would have been if it was not a whole. A. Do not lose the menu. Okay, aligned. Good. Keep losing this one. Go here and stay here. I need you to copy this one. Alignment to this one. Like this and like this. And then this one alignment. Oops, lost it. This one aligned to this one like this and like this. And then this one aligned to this one X and Y. I lost it. What happened there? It's not protruding on the top, which is strange. Did I move it? Okay, you go here. Like this, like this. Yeah, now it looks right. Like this. And like this. Okay. Where did this one go? Why is it low? It's lower. Crap. Okay. I need to get it out of there. 2 millimeters down, they ended up being okay. This one and that one, I cut it only on this side of things. Yep. Not right. Or is it? Looks right. And the last one. Go here. Okay. Now we need to take all the orange things out. That's not orange. That's orange. That's orange. Did I move something? No. Orange. Orange. not orange, 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 orange. So these shapes that I'm using here, they're already pre-calculated, pre-experimented with. So they are perfect, over perfect size already. So now we just take it like this, and we made a mistake here, as we can see immediately. There's, for some reason, a tiny sliver of it left in here, not supposed to be. So let's see, we have a hole and we have this misaligned. Okay, let's try again. And here we have a cup. It's upside down right now, the cup, but it would perfectly fit this. I can actually even like align them together to show you. So there's a microscopic gap between the wall. Actually, I need to raise it a little bit. So there's a microscopic gap because the size of these elements of these hexagons that I used already was pre-calculated. So this violet thing perfectly would fit this cap, this holder. So, and we're gonna need two of them for the top and for the bottom. So balancing wires. Balancing wires are pretty thin wires that go to the every serially connected, every serial connection between batteries, not parallel connection, but serial connection. So, and then it comes to the board, and to a special board that does what? It just, when you charge the battery, it just tries to keep the whole assembly, the cells in the whole assembly, more or less at even voltages. Because otherwise they get unbalanced. Some would charge higher, some would charge lower, and that would just, it won't result in a fire or explosion. Plus, I bought like how is it called, lithium phosphate, lithium iron phosphate cells. They supposed to be way less violent in terms of like producing fires. And if you don't use like the balancing board, it won't result in a fire or anything, especially not with these ones. But the amount of life of the battery is going to be diminished then. So okay, we got one design done here. So these three elements, it's one design. So it's like one shape of things. Pretty much almost square assembly. That's, I kind of like. But let's do another type. Because this one might not fit. And I have in mind another type that might fit a little bit better. I'm talking about a very specific box that already has boards and transformers in it. So, and I'm just trying to feed these batteries, which that box never was supposed to take, but I'm trying to fit this assembly inside because why not? So now I'm going to make another one that's gonna be a little bit harder. So another one's going to be hexagonal and sort of checkered, if I can say that. So let's see. I'm going to maybe even try to show you how it should be here. Just give me a second. So camera, here we go. So how I want it to be checkered? I want it to be like this. So I want it to be like this. And this is kind of easier. So these two connect together, go here, connect together. On the other side, same happens here. And then these two connect together to these two. And yeah, the terminals are on the other side. So sort of kind of checkered placement. Another design that I'm going to try just in place in situ. So let me get the batteries back into the holder. Again, they are heavy and I don't want them to accidentally fall off the desk. Gonna be loud. Don't want them to be rolling around. So we will need these elements for the start. But got to turn them 180. Yes. Not 180. A little bit more than 180. Minus 30 on top of it, like this. Then this one, do not change its size, goes here and gets turned like this, minus 90, and gets co-joined. No, this one's going to be not this one, my bad. This one is going to be minus 90, like this. Align to this one, move it in, do the cold 3D fusion in here on the micro level. Here we go. So, and then the same we get here. This goes here, gets turned like this, minus 90. Aha. We turn the assembly minus 30 to align them. So minus 30. So this gets aligned here. To this one, like this. Fuses with it. Fuses with it. Micro level. I cannot see the micro level for some reason. A micro level, here we go. And then another one. We take this one. Turn it 180. Align it to this one. Move it in on the micro level. Okay, so this is one part of it, but to be able to understand it easier, it has to be actually like this. Okay. Because the next would be like this. But I won't be able to join them, to align them properly. Or would they be? Let's see. So remove. Ooh. So let's bundle it. Copy the whole bundle. Ah, yeah. When I copy it, it doesn't move like vertically. It moves only on one axis. So it will perfectly align. I don't need to do it hexagon by hexagon. Yeah, as you can see, it is already perfectly aligning. Micro level. Please, can I have proper micro? That's not right. Okay, this is a little bit larger than that one. But again, we are talking about like maybe 1/20th of a millimeter, maybe 1/100th of a millimeter. So this is one side of it. Cool, right? So now we need to make another side. I'm just thinking about if we get any complications because of this microscopic less than hair fusions between parts. Shouldn't be, but just in case. Okay, let's start. It's a bundle. It's two bundles. Bundle it. It's not a bundle. It's a union. Let's make a bundle. I'm not ready to unionize them. So let's start making another one. Another one's going to have just the cups on the outside. Like starting with these two, right? -30. And then you get aligned here like this. And then we fuse you in. Ow. Cannot see the fusion going on. Not on the micro level yet. So these rectangle, these squares here, it's like square millimeter. So you can see how big it is. Actually, I'm actually far from them, so it's like this wouldn't be this side this size here. It's like less. Actually, probably can even measure. The software simply doesn't operate, I think, with this level of precision. So everything here is in millimeters. And it gives me the precision to like 1/100th of a millimeter. And I think with this microscopic fusions, I get it even to less than a millimeter. Okay. Turn the assembly. -30. Now we'll have to form another one like this, but mirrored. Another one like this here, but mirrored. -120. Like this. Go here. Here we have our microscopic fusion, do we? I cannot see it happening. Yes. Okay. Cool. Absolutely wrong position. It has to be... yeah. Being stupid. Apologies. Here we are going to need... They has to be mirrored, right? They has to be mirrored. Wait a second. They have a weird symmetry issue that I think I might end up forgetting about in this design. Give me a second. So these ones that are almost square, the top and the bottom, they are pretty much the same, but these are going to be different. Yeah, mirrored they have to be. So yeah, Fistmaster. Yeah, that's like the easiest way. Yeah, but I don't think this thing actually supports extrusion, and I don't think this thing supports like 2D drawing. I'm working with basic shapes here, so the only 2D drawing I can do here is like this, and then it gets extruded. So, but that's not really what I need. It's like free drawing, freehand drawing. I haven't figured that part yet. Haven't figured that out. Okay. Does path? Yeah, that I didn't know. Okay. That I got to learn how to do then. I just kind of just work with primitive shapes here. So draw shape. What was that? Okay, this can be done in a pretty insane way. Okay, that I don't know. Okay, back to our things here. So this has to be, this has to go here, this has to go here. So goes here, and then goes here. Let's see you print that, mister. Yeah, that would be something for sure. But I'm so amazed the things you can do these days. Oh crap. Just with CAD software and a printer. No, not right. Has to go up and has to go, So has to go like this and like this. So 120. Align. Then join. So a little bit of this overlap in to fuse them together. For the truck steering wheel, how did you print that? I mean, that had to be some pretty serious plastic or even metal. I think I don't know about here, but like in normal places you can order printing out of metal. PLA? Wow, okay. That's cool. That's so freaking cool. That part I like. I always like 3D Studio and stuff. I haven't done it in years and many years, but when I was just a child, 14 years old, a teen, I liked it so much, and now you can actually have it like made into something, not just on screen. Standard bearing shafts. Well, I mean, yeah, of course, but like, I don't know what loads it supports, but it's so freaking cool. I'm kind of just doing pretty much. I could just made this battery pack by hot glue and electrical tape. So what I'm doing here is just cosmetics pretty much, but still. And you made sort of kind of load bearing thingy. '16 fill, yeah. So what in field would you recommend? Let me actually show it to you. Let me show it to you here. So see, I have two variants of pretty much one design here. So these are like the holders. It's just unfinished ones. It's just prototypes. So this one has these connections, but I don't like them because once you weld the strips on top of the batteries, you won't be able to remove it. This one, you weld strips, but you still can remove it. But this one is flimsy, way flimsier than this one. This one's like super solid. So that's what I'm talking about. They're load bearing, serious load bearing. So I don't know the infill of that because I never requested any specific infill. So I only requested this to be printed as a draft. So this one's flimsy. This one's not because it has these connections here. What infill would you recommend to make it less flimsy? So 100% infill. Well, I mean, it's not load bearing, but especially this part here. And this, well, cannot really do anything. I gotta ask. So it's actually pretty transparent. I don't know if you can see it. Yeah, you cannot. But this is sort of kind of even transparent. A little bit. So it definitely lets the light through. So I don't know what infill would be this. I never requested any specific infill. So I just requested it to be printed as a prototype. Yeah, I'm just thinking, would 60 be enough for this? Because it's definite. I think it's definitely less than 60. So these parts here, they're like 2 millimeters thick, and they are translucent. So maybe this is 30. If you're saying maybe this is like 30 or 40, 60 would make it way sturdier. So this is again a prototype, not in the right shape. It's just to be able to see if the batteries even fit. They're not supposed to be like super strong. So this one here, it's 100% enough for me, the way they are. This one's a little bit more flimsy just because of these connections. There's no connections. They're absent. So, and they are going to be like in at room temperature at all times. So no load bearing, no vibration, nothing. It's going to be in a metal box on the wall in my closet. Metal box on the wall in my closet. No movement, nothing. Just pretty much. So this is super okay, but it's more sturdy just because it has these connections here. And this design is slightly different, doesn't have connections. So maybe this is like 30% in feel, and if I ask request it to be done with 60% in feel, it might just get sturdy enough. So it's not in moving parts. It's not even something that would be put on a bike. Though I kind of want an electrical bike on these batteries. Imagine like having two of these on your e-bike. I'm talking only about city e-bikes, city cycle, nothing extreme, no intercity travels, no like breaking speed limits of any source of type. Pretty much not more than 20 kilometers per hour, maybe. So imagine two of these like 30 ampere hours, 24 volts. It's like it's and supposed to be fire safe. Breaking speed limit. Wob, good evening, welcome. They'll soften the PLA. Yeah, so this battery, the one that I'm designing the holders for, never going to see currents more than like 5 amps. So no, the actually people kind of build e-bikes here that would go like 60, even 80. I heard about it, but yeah, ABS for the final print. So this one I think a standard one would be like this material would be 100% enough. So not going to be moved. Probably going to be additionally secured by some threaded rods. So it's just this shape. I would have used these holders, but this shape doesn't fit in the box. I want them have to. So these ones are industrially made. These ones I got with the batteries. These ones I printed. These are like prototypes. So I don't have a printer, so I only design, and then I send my designs to a guy with a 3D printer, and he prints them. So, but again, what I've been discussing, so this is probably done with 30% in feel or around, maybe even 20, maybe 40. So flimsy a little bit. So 60 I think would be just right. A St. Prince and well, yeah, it's not Sir, it's just a guy who lives like, well, not that far away. So okay, let's get back to the design. So now turn this back to normal position. That's not normal position. That has to be like this. So then this we take, we drop it in here. 120, please. Thank you, Fistmaster. Trying my best here. But again, I've done that before, not in CAD, in like 3D software. I've done that when I like was 14, 15, so it's not my first experience with moving like 3D primitives around, I don't know, grouping them together, cutting one primitive out of another primitive. It's not like the whole idea is super familiar to me. It's just computer assisted design that's like, and printing, that's the new part. But thank you. Okay, again, micro level fusion overlap. If you don't do these overlaps, this software starts sometimes doing pretty strange things on export. Are we good? It doesn't support the precision I'm working with here. And I don't need that precision, but I kind of like things to be super precise. So move you in. Micro level fusion overlap. So the zoom even breaks at the level I'm trying to do it. Yep, we have the tiny overlap. Okay. Then you, oops. You go back to 60. Oops, my bad. This. Fist, thank you. Yeah, I'll do it. I'll definitely do it. I just these designs, the simple ones, I'm going to finish here, but when I switch to more hardcore things with like really uneven, non-symmetrical curves, yeah, that's gonna be Fusion 360, because simply I will have to draw like really smooth curves, extrude them, then print them, then check if they really align IRL, and then readjust, so things like that. Okay, so, and then we need these two here. Like this and like this, yes. Dun, dun, dun. Pum, 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 pum. Oh yeah, the slicer thing, I didn't even get to that part. Well, because I don't have a 3D printer and I don't think I'm going to have. The thing smells, the thing takes space, and it's already pretty hard for me would be to find any room for it. My apartment is too small and I already have quite some stuff here. But it smells, it produces chemicals, and I have really small animals here called degus. For them, even these small doses of chemical agents might be harmful, because simply they do not have a lot of weight. In virtual print, I know the virtual. So, but again, I send the design to somebody else and they would do it like their own way. Well, they actually just a little bit less of a size than a red. So reds can be pretty big. These guys, they're pretty much like in the size of a squirrel, but they don't have like long big furry tail. They have like naked tail with sort of kind of brush on its end. So okay, so here we have the design. So let's see if they align. That's bottom, that's top. So if you give me a second. So just give me a short sec. Pum 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 pum. Let me find some photos here. Just a short sec. So I'm not really a data hoarder. I'm trying not to be a data hoarder. So, and because of that, my photos are not really organized. So, but yeah. Oops. Let me do it again. Like this. So that's the ones. That's not. These are not the current ones. That's from more than couple years ago. One's passed away already. Another one's alive. Plus we have 3 more colored ones. So this is like the standard color of them, called agouti, I think. So a standard gray, but they can be black. They can be sort of sand color. I don't remember the right name. So I wish I could give you the current photos. Just give me a sec. Just give me a short second. Just a short second. Not that easy, but doable. Got one that I can show. Camera. So I don't have like all the best photos at hand. So there's a couple. Let me copy them to the server. Here we go. Just a second. Yeah, the second photo is not great. So here we go. So that's the 3 young ones that we got this summer from Moscow, actually. Turned out that Russian railroads have a service where they would deliver your animals if they are in cages. If they are like in cages and cannot harm anybody, cannot get outside. So they would deliver them for you. You'd have to sign a bunch of papers, but that's the service we used. Like a company that breeds them in Moscow sent some using just the railroads. They are getting transported. The railroads, Russian railroads, transport them as passengers in passenger train cars. So in actually train car with the conductor of the train car. So they were packed in a small plastic box, traveled from Moscow to our city, not that far away. So not that far away from Moscow. And yeah, thus we actually avoided going to Moscow. It's funny, yeah, that you can pretty much, you give your cage to the conductor, you buy the tickets, you sign the papers, you give your cage to the conductor, you tell the conductor what to do with them. In this case, the conductor had nothing to do with them, just place them in a corner, and so don't forget to hand it off. So, and yeah, that's how we got them. So, but it was funny. My wife had to, she was the recipient. She had to sign a ton of papers in the train car, and the stop for the train was actually pretty short on our station. So, and let me see. This one here is like they're in a different cage, unfortunately out of focus. I didn't see on the phone that it was out of focus. So, okay. So 3 daggers. One gray, standard agouti color, one sand color, and one black. So yeah, okay, back to the designing things. Just a second. We got interrupted here. And not the right cam. Here we go. So let's see if these two parts actually essentially WAP, they don't really have a history of domestication. I think they started getting domesticated only like around 30-40 years ago, maybe even 20, I don't know. They naturally come from Chile and maybe Peru. They live kind of at the foothills of mountains. In Chile, I think they call them singing mouse of Chile or something like that. So essentially they are wild. They're all wild. There's no history of domestication of any reasonable longevity. So, but they are super smart and they live with humans just pretty well. But of course they want to chew everything. So, and whatnot. So they can be hardcore, pretty hardcore as pets. Okay, let's see. Oh yeah, I mirrored it just right. So this goes on top of this one. Ha 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 ha. Perfect. So I mirrored it absolutely right. So this aligns. These two parts align together very, very, very well. So now the terminals. Let me see where to make the terminals here. Okay. You go out of here. So it's going to be on the side if it's inside. So this is going to be like up, this is going to be down. So this is one terminal, one side, this is another terminal. Just to make the terminals completely hidden, sort of kinda, because it's going to be in the metal box, for them not to touch anything metal. I think I'm going to cut here and here for them. So like plus and minus. Yeah, okay, let's do exactly that. You go here. No. Unbundle, please. How do I ungroup you? Here we go. Like this. Hey. Did I realign it? No. Did I break them out of alignment? You go. Oh, stop. You go like here. And then you go up like this. Huh. Oops. It's 2 millimeters. It should be 1 millimeter snap. Yeah, 1, 2. Here we go. That's how we cut them. Cut. Okay, that's one terminal. And the terminal is going to be, I think, just the strip coming there and then bending, well, what's down for us. So going like this. So that's gonna be the terminal. And then let's do the same here. For that, we'll have to turn it again. 67. Can we just have 60? My bad again. Cannot use the... I'm super used to my numpad. I cannot live without numpad. I don't understand how people do anything on keyboards without numpad. I use it all the time. But when I stream, it is actually used for controlling OBS. So I cannot use it as a numpad. So that's why when I try to type numbers here, I end up just switching scenes in OBS, and I constantly try to type numbers there. Yeah, this part needs to be breached. You're right. Well, I mean, I don't actually need to, because there's going to be a cap. There's going to be a cap. So I don't even need, well, I mean, just as a... let's think about it. I don't want to breach it because I want it to be completely removable. So yeah, gotta think. So probably I'm not bridging it, so it gets printed maybe a little bit separately, but then there's going to be a big cup. So, well, technically, yeah, but it's like, again, a spacer of sorts. So I would prefer to have it. A cap going to be just holding things together. I could maybe even like glue it to the cap. Maybe I could print it into the cap. Actually, that would be even more interesting. Printing it into the cap. But that's like the level of design I'm not sure I can do with that. Yeah. No, it's not going to drop. It's not going to drop in because see, it has like clips here. So, and even this one. So these are for these sides of the batteries. So it's going to hang on these lips. The walls on the cap. Yeah, on the cap. Well, I mean, don't want to overcomplicate it just right off the bat. I mean, for me, it's a little bit too complicated already, but, well, we can do it, but just by step by step. Okay, so here we have the upper, well, I mean, let's consider, because it has a terminals, just like the car battery, let's consider this being like the upper part, the top part, and then the bottom part. In order to group that part into the cap, I'll have to have it separated from everything while being inside the, okay, we can do it. There is a way. Yeah, there is a way. Cutting everything around it, cutting off everything around it, and then doing it just inside the cap itself. Yeah, that'll do. That will work. So, but first we got to make the cap, cut it, then place this thing inside the cap, cut everything that we do not need, leaving only this small centerpiece, and then attach it to the cap itself. So yeah, that's the way to do it. Okay. Again, this design doesn't account for the small wires that are supposed to be like balancing the cells. I think I would just use a small file to make like grooves for them, small grooves. Okay, so let's start working on that cap. So they are mirrored technically. Yeah. Can we have it 90 degrees back like this, and this one? So then let's turn it upside down, 180 like this. That's easier for me to control what's going on like this. So now let's make a cap for this one. You go here. Let's start just copying you all over the place. Align. The first one. Align. That's first pair. Then you align. There's a small hole here, but everything looks even. They're not going to feel it, this hole. Strange, but okay. Is it even possible? If it worked here, it should work here. Okay, let's see. If I'm just... Sorry, I'm an idiot. Yeah, I'm an idiot. Like this, it has to be. I forgot to turn it properly. I would have noticed it one way or another. I would have. either here or a little bit later. I would have. Square hole. Yes, exactly. Pum, 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 pum. Okay. And the last one. Oh, pum, 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 pum. So we have these here. Yeah. So then we can copy and mirror them. So that's gonna be not a problem for the upper cap and lower cap. They're just going to be mirrored. Now you so if it aligns like this, yeah. I'm doing actually right now, I'm doing the cap for not the one that's inside. I'm doing the cap for this one, but because it's all mirrored, but that's sort of kinda doesn't matter. Can mirror them later. And that ends up being copied 2 millimeters lower than it's supposed to be. That's why I copy and paste it, and then end up being pasted 2 millimeters lower than it's supposed to be. Not sure why is that the default behavior of pasting. So if I just don't copy, if I just paste from the buffer, yeah, it is lower. Kind of tries to stick maybe to the plane, but if I copy and paste, it stays on the right level. Do not do that. Do not do that. Did I move it? No, I didn't. Okay, get you. Okay. Take the green one. Copy it. Oh, God. Just give me a second here. Take the green one. Copy it. Move it out. Like this. Now take it from here and copy it from here. Yeah, that's the way. And then here. Right. And then the last two goes to this hexagon, and then the last one goes to this hexagon. So technically we can do cutting. Oops, I didn't copy the design. A problem. The design that's underneath it, that's the only copy. And it's not even properly bundled. Okay, let's get it out of there. How to get it out of there? If I do it like this, 24 shapes. It's all of them. Crap. Only the visible ones I need. Crap. Okay. Okay, so these are all these. Oops, stop. All the hexagons here. Bundle. Remove it. No. Uh-huh. So this V bundle. Are they still there? They seem to be. Okay. Now we take this. We bundle it. And we maybe move it out of the way even. Yeah, we move it out of the way. So now let's drop everything back to the plane. Uh-huh. Uh-huh. Now unbundle them. And let's copy before cutting anything. And let's do the cut. We have one cap. And this is the cap for this one. Yeah, just by the shape of it, this is the cap for this one. So we take this bundle then and try to align it with this one. Yeah, okay, let's move it. Let's make a copy of this shape. Is it clean? Supposed to be very clean. Okay. So let's see. It has to be a little bit higher like this. So now it's perfectly inside the cap the way it's supposed to be. This small distance, yeah, it's there. And now we are doing what? We are doing very rough. We're going to do very rough cutting here, like this, and then this maybe. Yeah, that almost worked, but I need this cutting block, as I call them, to be a little bit just larger. Okay. Then another cutting block. Like this. cut again, please. Perfect. And then another cutting block. Like this one. Yeah. So cut, please. And another cutting block. Like this one. Here we go. So now we have this thing here. Let's see if it seems to be attached. There's no gaps, only maybe if microscopic. So maybe if I like do it like this and then move it one microscopic step inside the purple cap. So it is up and this is down like this. So just one leftover hair, it's submerged into the purple cap on a less over hair depth. So we have pretty much this. Yeah. So we don't need this part. We don't need this part in this assembly here, because this part is now in this assembly, which is super cool idea. Didn't think of it. Thanks to Fistmaster, who got me this idea. Okay. Now unionize. So we are starting with basic primitives like a couple circles, a couple of cylinders, a couple of hexagons, and we end up with shapes that are as complicated as this, which is sort of insane-ish. And it should be flush with the cap itself. So okay, now let's make another cap. So this is for this one, right? Right. Now we need a cap for this here. No, I know how, because this is not my first design. This is definitely my most complicated design. My first design, actually, let me show it to you. Just give me a sec. So this is my first proper design, this front panel for old retro PCs to make them more convenient. Yeah, it doesn't look like something period correct, but that's for convenience, not for period correctness. So one side's for CF to ID, another side is for SD to ID, and this here is for USB. Of course, it's like modular too, because this is a module, this one module, this is a module, this is a module. So I can design this 5-inch bay, 5-inch drive bay front panels pretty much with any configuration of, like, I can put this couple same cards here. I can remove USB, I can add something USB with holes, for example, for for sound, but the old PCs, they, even if you wanted to have sound on front panel, you'd have to connect to the back of the sound card of the old PC. So the sound cards of that era, they don't have outputs for the front panel. So this is an example already with mounted CF card adapter. So it's just with one CF. So as you can see, that's what I was talking about. That's the filament I found, and it was recommended as like something for retro. And the color maybe is a little bit off because of the camera. The camera makes everything green. But you can see this is like way closer to Commodore color. Sort of kind of, I don't know, light, super light chocolate milk, diluted cocoa, something like that. So I just spray painted the front panel with just white spray paint for plastic. It's maybe not even a paint, and maybe like a, how to call it right, something to pre-treat it. Well, aged Commodore. Yeah, that's the thing. So, and I needed white. I needed old white. It's not like, if it's off-white, it's not like, I don't know, your bus stop white, not like that type of white. It's a little bit still faded. It's off white. So I ended up just painting it, spray painting. So, but the paint actually looks good. A couple of layers, and it's sort of kinda bread bean beige. Yeah. So it's this type of beige. So maybe it would be okay for that bread bean Commodore, but definitely it's not like the old white PC cases. So whoever was discussing it was discussing retro computing, but 8-bit retro computing, not PC retro computing. So yeah, that's my first proper design. This thing is here. Quite complicated too, but because it's modular, so I have a module for CF to ADE adapter, I have a module for SD to ADE adapter, and I have a module for this front panel USB with audio and without audio. So okay, oops, that's wrong key, apologies. So let's get back to our design here. Now we need to make cap for this one. So let's mirror this design like this. I hope this doesn't break anything. This is not really needed anymore. Oops. So this goes here. This is a bundle, so goes to the side. And this is finished design. So this goes here. So hide inside the cap, please. Perfect. Let's move you couple millimeters up to make you flush. Are you? Yeah, you are. Yeah, as flush as it gets. Well, I mean, I could just use aligning in a vertical plane, but whatever. Vertical axis. Now we need to do some cutting again. Cutting blocks, as I call them. So just going to make a bunch of them at once. Hope it works. They are all not of the right tallness. height. Okay. Got to be careful with what we are cutting here. Okay, like this. And this. And join. Take some time to process. Hope it doesn't crash or anything. Here we go. Everything's cool. The outline shows that there's nothing outside left, accidentally, like some microscopic sliver of thingy left. We ended up without music. Oops, wrong one. So yeah, by the way, speaking of music, if you're watching me on YouTube, you are not going to hear any music ever. If you're watching me on Twitch as a recording, you're not going to hear any music either. The only way to hear music is to watch me on Twitch live, so pretty much I cannot get to this one anymore. Super. So pretty much if I'm talking about the music and you cannot hear it, it's like only for live viewers, doesn't get recorded because of all the problems with the content ID systems and whatnot. How do I get to this one? How do I get through? Okay, I don't need. I just realized. Because these two things here and the one in the middle, it's like one thing. Okay. Now again, that microscopic overlap to few things like this, and we have this one ready to bundle. Perfection. So this is just a product, a byproduct. You go away. So the designs that we the designs that we have, it's like this one, and this one, then this one, this one, and this one, and this one. So okay, so oh crap, just a sec. So here we go. Here we have well, I got a well, this is just going to be removed by the printer, so because it's not connected to anything, or I'll remove it later, doesn't matter, the center part later before exporting. For now I'm keeping it like this, just bundled together as a bunch of intricately cut hexagons. So this is like the top part. Yeah, this is the top part, what you would call the top if we are looking at it just like at we would be looking at the car battery. So, and top cap or lid, and this is the bottom part and the bottom cap or lid or whatever. So, and this is like another variant of it, a different configuration of hexagonally aligning, placing them together, the cells. This is like the top part. So maybe actually that nickel terminal would be smart to move there, to have them at least looking in one direction. The terminal with, okay, we'll see about that. We'll see about that. And this is the bottom part, and this is like the cap for both top and bottom. So pretty much. I will export this a little bit later on my own. I'll think about it a little bit more. I'll maybe try to check some things, but everything looks as good as I can get it. So I guess at this moment, at this time, I think we are done with these designs. I kind of wanted to do another design, a straight lines of two hexagons like this. So these are like diagonally broken lines. I wanted to do two straight lines, but they won't fit because I think they won't fit 100%, where I would need this battery to be. That's like a limited room in there. So I'm not even going to bother with the straight line of hexagons design. So thank you, Fistmaster, thank you. These are the most complicated designs, but again, I really like that we started with just one hexagon and a couple of cylinders, and a couple of just rectangles. That's not rectangle. What's the name of this shape? Box. A couple boxes. Yeah. From the holders. Yeah, I will remove it on export. So, or we can do it now. I just have to again save the copies. So, cutting block technique. Are we going to fit just inside? Yes, it does fit. Good. Don't want to accidentally cut something we don't need to cut. You go higher, you go lower. And here we have a hole, by the way. I need you. And you can just be cut. Here we go. Now you the alignment, the snaps off. That's why it feels so weird. Okay, is it good? Good, okay. The next one. It is lower than the plane of the part. Here we go. Cut it out, please. Here we go. Perfect. But these ones, they're going to be actually, I think because of the way they're designed, they're going to be pretty flimsy. So they, maybe this one's not that flimsy going to be because it still has like some connections here. Well, there's a problem here. It's not supposed to be like that. Crap. So if there's a line, there's a problem. Okay, let's see, how did we get there? Here we don't have any joining lines. I know just when the problem starts with this software. So if we unionize it, do we get the line? Come on. We don't get the line when we unionize it first. Okay. Then take it as it is, then turn it into a proper union. So no lines here. Then let's use the cutting block again. That's my terminology for this thing. I don't know how to call it. It's like pretty much playing Legos, but with pieces of different sizes. Okay, and then we unionize this. Union, please. And then it appears. Okay. Okay. It's not supposed to be like that. Best kind of Legos, yeah. So then turn it. So 60 degrees like this, please. Yep, then unbundle it, please. How do we unbundle it? Like this. Then we take this one and we just fuse it a little bit more, like this. It actually was invisible. Oh yeah, it's not fused. Now it is. So then we can bundle it again. Minus 60. Then we copy it. Then we turn into the union. Here we go. Then we use the cutting block. Good, good. Here we go. No joining lines, no fusion lines here. There are lines, vertical lines here. I hope they are not going to add any complications. But we at least don't have like the lines on the surface of it. I know that it might be a problem on export. It might not be. It might be a problem on export because I've seen it before. If you see some lines, some stitches, some seams on your unionized part, on export it might start doing strange, weird stuff, adding polygons to it and whatnot. So okay. So one design, well, one part, two parts, three part, four part, part one, part two, part three, part four, and then part one, part two, part three, and 2 copies of this one. Okay. So that's quite a print going to be. Cool. Very cool. Okay, exporting, it can pose some other problems, but that I will deal with a little bit later. So let's call this a stream for now, but let's call this a stream for now. Just give me a second. Here we go. A good thing that you don't need to press save here. This thing, Tinkercad running in a browser is going to save everything for you, unless, well, I mean, you need to export it. Exporting it, it's not saving, it's exporting. So thank you very much for watching, everybody. Don't go far away, because I think I'm going to do a second stream. But in order to do the second stream, I will have to stop this one, because it's going to be different category on YouTube and different category on Twitch. I know that I'm going to lose the viewers, but I need everything to prepare for the second stream, because I'm not ready right now. So I'm going to need like some time. So we'll continue with a little bit of fun in a little bit. This is it for this one. I will see you, I hope, pretty soon. YouTube people, thank you very much for watching this on YouTube. If you like this sort a little bit educational, more like just tinkering and learning video, please leave a like, subscribe for more. It doesn't matter if you're watching this as a live video or recorded video. So leave a like, subscribe for more. We will do another stream just in a bit. Twitch people, thank you very much for watching me on Twitch. I'm not going to do a raid right now. I'm just going to stop it to continue it in a couple dozen minutes with a different one, with a different stream. So again, quite some lurkers tonight I could see. Feastmaster, thank you for jumping in and keeping me company. WOP76 and Gonna Getcha, thank you very much for jumping in. We will continue in a bit after a short offline break. So everything goes offline, and then in a couple dozen minutes it goes back online. So that's how it's going to be. So see you in a bit.